Hello and welcome everyone. This is Steve Suffoletto, formerly with Rochester Institute of Technology, RIT, in Rochester, New York, and SUNY Erie, State University of New York, Buffalo, New York. This presentation is titled Color, Tint, Tone, and Shade. During this presentation, I will define and show visual examples of tints, tones, and shades. Visual color assessment or description requires effective communication with written and spoken language. Some people may use terms that are not technically correct or different than we use as professional printers. The word terms and adjectives we use need definitions so we can share a common and standard meaning. This is also true for modern instrument color measurement with a spectrophotometer using colorimetry metrics of delta E, L star, A star, B star, C star, H angle, delta H. Let's define a tint. If we look at this solid blue color here and we add some percentage of white to it, we get a new resulting color called a tint. So a tint is the result of adding white to a color. A tint will always be lighter, so its L star will be high or its delta L will be plus. If it's a much lighter tint, you can call it a pastel. Pantone actually has a fan guidebook just for pastel colors. For spot color special ink mixes, the white is an ink or paint. A paint is lower in viscosity, an ink is higher in viscosity. For process colors, the white is from paper showing through the halftone screens, whether they be traditional AM amplitude modulation dots or frequency modulated FM spots. Regardless, white paper is showing through. Here's a progression from left to right of a color getting lighter and lighter and lighter as a tint. Next, let's look at a shade. If we take a blue color and we add some percentage of black to it, the resulting new color is called a shade. A shade results when black is added to a color. A shade is always going to be darker, so its L star will be low, closer towards zero, or its delta L will be negative or minus. I like to think of a shade as the sun being blocked by the tree you're sitting in the shade. When you put a pair of sunglasses on or shades, everything gets darker. And here's a progression of a shade getting darker and darker as we go from left to right. Now let's look at a tone. If we take that blue color and we add a percentage of gray to it, we get a new color called a tone. A tone results when gray is added to a color. Gray is the combination of white and black, or black and white. To the right there you see a gray scale going from left to right, from white to black, or highlights, midtones, and shadows. Gray is neutral, it's hueless, it's achromatic, the prefix a meaning without or not. Alternatively, adding a complementary color, an opposite color, an opponent color, will act as a gray and result in a tone. This is the pre-pressed black generation color separation principle for gray component replacement, or GCR. Now let's look at a scale of grayness going from left to right, increasing in grayness. In summary, if I take a color and I add white to it, I get a tint. If I add black to the color, I get a shade. And if I add gray to the color, which is a combination of white and black, you get a tone. So now we have a definition for tint, tone, and shade, the addition of white, gray, and black, respectively. Let's look at this another way. If I take a color wheel or a color circle and have on the outside circumference the hues, and then I add white to them, they now become tints. Moving inward, if I add gray to those, they become tones. And moving inward again to the very center, if I add black to those, they become shades. So this illustration shows you the hues and their tints with white, tones with grays, and shades with black. Let's look at the correlated or associated colorimetric values for tint, tone, and shade. Again, tint is adding white, so nothing happens to the hue, it stays the same. The value will get lighter, so the L star will increase, or the delta L star will become plus or positive. And because white is a desaturated neutral, the chroma will decrease and get lower. For a shade, adding black, the hue should stay the same, not change. But the value will get darker, the L star will get lower, closer towards 0, the delta L star will become negative or minus. And again, because black is a neutral color, desaturated, the chroma will get less, lower, negative. Finally, let's look at a tone, which is the addition of a neutral gray. The hue should stay the same. The value should stay the same, but the chroma will decrease. In summary, when assessing color visually, verbal legacy terms such as tint, tone, and shade are often still used. This presentation gave definitions and examples for a tint, tone, and shade. Modern color measurement technology with spectrophotometry and colorimetry can replace tint, tone, and shade with L star or value and C star or chroma saturation. Here's an 8-question quiz. Let's look at each question individually. Is hue the same as color? No. Hue is the basic color. We use this to categorize its general group names such as red, orange, yellow, green, blue, indigo, violet. Hue is only one dimension of color, so by itself it's incomplete or partial. Color consists of 3 components, attributes, or characteristics. They are hue, value, and chroma, used by Munsell. In colorimetry, we would refer to these as the L star, lightness, darkness, chroma, clean, dirty. What makes a tint? The addition of white, either with an ink, spot color, or with white paper showing, processed screen tints. What makes a shade? The addition of black. What makes a tone? The addition of gray, or the complement, the opponent, the opposite color. What 3 colors are neutral? Well, white, black, and gray. All these colors are neutral. They're hueless. They're achromatic, the prefix A meaning without, not. Neutrality results from equal balanced amounts of red, green, blue light, the additive system, or cyan, magenta, yellow density, the subtractive system, or unequal amounts of cyan, magenta, yellow dot size area. For example, 50% cyan, 40% magenta, and 40% yellow. If I had equal amounts of cyan, magenta, yellow dot size, 50 cyan, 50 magenta, 50 yellow, this would not look neutral gray. This would be on the warm side. It would look brown and orangish. So the individual primary ink color channels, the cyan, the magenta, the yellow, they're adjusted or curved to result in a halftone dot screening gray balance. What are the complements to red, green, and blue? Well, again, a complement is an opponent or an opposite. It makes the color complete. In the additive system, complete is 3, white. And in the subtractive system, complete is 3, black. So the complement to red is cyan, the complement to green is magenta, and the complement to blue is yellow. So a blue sky plus a yellow sun equals a white daylight. No, it won't be green. You're not a Martian. You're on Earth. You're an Earthling. Now, complement colors are used for Kodak Raton color separation filters. The 25 red is used for cyan ink, the 58 green is used for magenta ink, and the 47 blue is used for the yellow ink. What hues are cold or cool? Blue, green, and cyan. Blue plus green is cyan. So this would be the lower left section of the color space from -B to -A. What hues are warm or hot? Yellow, magenta, red, and orange. Yellow plus magenta is red. Adding a little bit more yellow to the red makes it an orange. So this would be the upper right section of the color space from +B to +A. Now the red overprint ink trap may look orange because of the unwanted absorptions or hue errors in the inks. Wet trapping yellow over magenta, Y over M, in the ink sequence, rotation, or order makes the orange look a little redder, so it provides some slight automatic color correction. Thank you for taking time out of your busy schedule to watch this video. I hope you found it interesting, informative, and useful. If so, please click the like button and share it with others. If you have any questions or improvement suggestions, please leave a note in the comment section. Goodbye for now.